Hi. So for our project, we built a heads or tails coin toss simulator. I'm John.
I'm Eric.
I'm Scott.
So for coin toss, you'd have two outcomes, which would be heads or tails. Each option, you'd have a 50% chance of getting each. So an example of what we're kind of visual, we'd have, for the first toss, we'd have a heads or tails. Second toss, you get another variation of heads or tails, and then a third toss, another variation. So you'd end up with a sample space looking like this. This is just kind of displays how we calculate the probability here. This example is with 2 coin tosses. So for the first toss, you'd have a 0.5 chance of getting either. And then adding a second toss, we'd have another 0.5. So we'd have 2 halves is equal to a fourth. For our example, we added a little bit more depth. We went with 3 coin tosses just so you could really see what was going on. So it was the same example as before, except when you get to the fourth, we add another variation, which would end up with another half, so making it an eighth.
All right. Now we're going to show you our apparatus. We built this where we have 100 LEDs, a PIC processor where we programmed this in C, and the 2 processors that are running the LEDs. Now here is right now our run. Now when this was programmed in C, we programmed it where we would have this show us the amount of values we have in binary. Now 0, 0, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 0, 0.
Before we move on too much further, I do want to show just one more aspect of this. The complexity of how these wires are each individually just kind of tied, and this was really tedious and time-taking. Because each one of these lights has to be tied in specifically to each post. But from here, we have to go over how to count the binary numbers, because you get the output, but then you have to do something with the output. So with that, you start off with, we read numbers in binary from right to left, not left to right. So each place, look at it as a placeholder. 1 and a 0, on and an off. Kind of look at the 1 as an on, so when that 1 is there, that means that number is being counted. So this is the 1 spot. These are 2-bit numbers, so each one has about a 2 spot. So it's, the first one is the 1 value, second spot will be a 2 value, next one will be a 4 value, this will be an 8 value, and that's where we stopped. We only used 4, but the example here shows it with another one which is an 18. So for that, we're going to add these numbers. It's kind of hard to see. This first one is a 0, 0, 0, 1. And you look at this, that means we're only taking the on from the 1. That means this number is 1. And the next one is 0, 1, 1, 0, which means we're only taking it from these 2, which would be 2 and 4. So that makes it 6. And for this other one, which was 0, 1, 1, 1, this means the only thing different is the 1 spot from the one previous, which makes it 7. I'm going to, for the sake of time, I'm going to move on. 1, 7, 0. So that's basically how we count the binary and how we read our data. Now, so we did 2 different simulations here. We did one where we just took the flips, we added them up. So this would be 14, 8. So this gave us 21 heads out of 50, because we're just running around at 50. So it's 21, 22 heads. Apparently I can't add. Lucky it's not graded on. Going with that. 22 out of 50. So that's kind of like, we did this again 10 times, so we would run this 9 more times. You're expected to get 250 heads, 250 tails. Ours, we got 265 heads, there's 235 tails. That's just over 50%. That's it's really close enough to mean that this was done correctly and accurately. And then so we would take this one more step further, and we looked for sequences. So as you can tell, we took down 2 3-block sequences. That being said, we can then take these numbers and we turn them into heads or tails. for what we did, we took the odds as tails, evens as heads. So the first one's odd. That means it gives us a tails. It's even, heads, tails. This one's tails, tails, heads. So for this, we ended up with a tails, heads, tails, and then tails, tails, heads. This is just for this run. This one was not done in our sample. So actually they were, but we got one of the ones we didn't get. So when we ran this, we did this 8 times. This was 2 of them, so we did this a couple more times to get our numbers. We got tails, tails, tails 3 times, which is a really outlier. Then we got a bunch of these other ones. We all got them 1 out of 8 times. And then we got heads, heads, tails, and tails, tails, heads, none. So that just, in the end, those are all really close to 1.8. And the majority of our data lies in the 1.8 range, which is definitely where we wanted it to be and kind of right along the lines of what we were expected versus the values as we saw in the charts earlier. So with our simulation, we were able to run both these tests to kind of show what was going on with coin flipping and how we can get sequences or just heads versus tails in the end.
Yep.
And here's a final thing, that the reason why this was programmed in binary is because most of our class is CS majors. So this was a treat for you guys that way. Instead of it obviously being, okay, how many LEDs would show the amount of heads or tails, we would actually have it in binary, read that, and calculate it